So this was the problem given to us. Lines PQ and RS are parallel to each other, and angle MXQ was given as 130 degree and angle RYM was given as 40 degree. And your question was, what is the value of angle YMX? So the lines are parallel to each other, but I don't have a common transversal. I have two transversals here, this one as well as this one. So there is not a direct connection happening. Obviously, I can stretch it further here and start connecting things. Okay, this is 130 degree and then do more stuff. But let me not do that. Instead, let me draw a third parallel which is passing through M. Let me call it line A. So now line A is parallel to PQ as well as RS. There could be another interesting theory problem for you. It is given that PQ is parallel to RS, and let's say it is given that RS is parallel to line A. Prove that line PQ is parallel to line A. So start thinking about this problem for a little bit. It's going to be very easy to prove. But as of now, I'm assuming that line A is parallel to PQ as well as parallel to RS. And let's see what we can do with the question first. Now, if I look at this line and this line, this angle and this angle are the interior angles on the same side. So if I call it X, I know 130 plus X is equal to 180 degree. What is the result that I am using? Interior angles on the same side of the transversal, their sum is 180 degrees. So this part is 50 degrees, right? This angle is 50 degrees. And now if I forget this story and I look at line A parallel to line RS, I know this angle and this angle, notice the Z shape, are alternate interior angles. That means this angle is equal to this angle, which is 40 degree. And the angle that I wanted to find, the YMX angle, is the sum of these two angles. So I can very quickly say 50 plus 40 is going to be 90 degree. So my question is solved, fairly easy, just repeating the key ideas that alternate interior angles are equal to each other. The sum of interior angles on the same side is equal to 180 degree. And I hope you've been working on this problem. And the problem is that I give you a line PQ and I tell you that line RS is parallel to PQ, given that PQ is parallel to RS. And I give you a third line, XY, and I tell you it is also given that RS is parallel to XY. Prove that PQ is also parallel to XY. Now it is very intuitive. It is almost visible to me that this is the case, but how do I prove it? Draw a transversal across and just compare the angles. I know this angle is going to be equal to this angle because they are parallel and these are corresponding pairs of angles. And I know this angle is going to be equal to this angle. That means this angle is also equal to this angle. That means the corresponding angles are equal to each other, and I'm using the same result backwards, that when the lines were parallel, the corresponding angles were equal to each other. The corresponding angles are equal to each other, that must mean that the lines are parallel to each other. The proof is as simple as that, and you could have gone for any theory and you can prove everything, because once you know, because as you noticed earlier, the moment you notice that the corresponding angles are equal, all other stories are also going to kick in, and that is very easy to derive. The idea being that the same results that you have derived from parallel to the connection between angles, you have the connection between angles, you can go back to the story that the lines are parallel to each other. That means if I tell you that there is a pair of lines and there is a transversal across and the alternate interior angles you notice are equal to each other, it wasn't given to you that the original lines are parallel, but it is given to you that the angles are equal to each other, you can conclude that the lines are parallel. Or it was given to you, I tell you that there are two lines, I do not tell you that they are parallel, but I tell you that this is 130 degree and this is 50 degree. So you add them up and you say, okay, these are 180 degrees. That means the sum of the angles on the, that means the sum of interior angles on the same side of the transversal is 180 degree. That means these two lines must be parallel to each other. That means we started off with parallel and derived the results about the angle. Now I'm using the information about the angle to derive whether the lines are parallel or not. A fairly easy proof, just covering it for the sake of completion. So this was the story given to us. Lines AB and CD are parallel to each other, as well as lines CD and EF are parallel to each other. So at the very onset, I can also say that line AB is also going to be line parallel to line EF. The other thing given to us is angle BAE is 90 degrees, and it is also given to me angle BEF is 55 degrees, and I am supposed to find the values of X and Y and Z. A fairly easy question, can be done fairly quickly. This is 55 degrees plus Y, because these are interior angles on the same side of the transversal. These are the parallel lines. These are the parallel lines EF and CD, and this is the transversal. So we are talking about the interior angles on the same side of the transversal. Just rotate this figure and you will see. So 55 plus Y is going to be 180. Y is going to be 125. 180 minus 55 will give you 125. Now if I look at line AB and line CD, these two angles are corresponding to each other. That means if this is 125 degrees, this also would be 125 degrees. So I've got the value of X, I've got the value of Y, I just have to figure out the value of Z now. And remember, as you try out these geometry questions, you will often see multiple ways of approaching them. Some people might see a triangle in here and start using the properties of triangle, but as of now, I just want to stick to transversal across a parallel line. Now notice that lines AB and line EF are also parallel to each other. That means, and the transversal is this line. These are the parallel lines, and this is the transversal. That means this angle and overall this angle are the interior angles on the same side of the transversal. Same logic here. A and B and E and F. That means I can forget about this C and F for a minute, and I can also forget about this. So the diagram is more clear to me. This angle and this angle, once again the sum is going to be 180. 90, and this angle was made up of angle Z and angle 55. That means this angle was 55 plus Z. That means 90 plus Z plus 55 is equal to 180, and I can figure out the value of Z. That last step I'm leaving for you. So once again, a very simple story, but just instead of one line, there were two lines and there were multiple angles to form. Very basic practice to repeat the key ideas that we have learned so far.